Okay, so the next system I want to look at is CouchDB, which began in 2005, but is undergone a lot of updates and is still pretty popular today. And so this is an example of one of these document-oriented stores that Rick Cattell talked about. And so here, just to look at the features we're talking about here, we've got the scale, we've got primary index. Now we start to see the requirement for secondary indexes, meaning that you can look up not just by the key, but by other kinds of values in the document, and we'll see how that works. Okay, and then transactions also are a little bit better. We can, what I mean by record here is that you can change multiple values within a single document object, which is a set of key value pairs, as opposed to just a single key value pair. Okay. And then there actually is some support for analytics, and we'll see how this works too. This is all through this concept of views in CouchDB, but you can actually run little MapReduce scripts to compute, derive new values from existing document stores. All right, and then the other notion we have here is views, which is somewhat unique. You can see this column is fairly sparsely populated, and I hit the concept of views pretty hard when we're talking about relational databases, and argued that it was pretty fundamental to not only the relational model, but a pretty important concept in general. It gave you this notion of logical data independence. And so whenever you see views, that's a good thing. And so CouchDB has them as well. All right. So the data model here is documented oriented, as we said, where a document is a set of key value pairs. And so here in this application, these are perhaps blog posts where they have a subject, the key is subject, and the value is some text string, and they have an author, and they have a date on which they're posted, and then they have a set of tags, and this is sort of what makes it a document model. We said they could be sort of nested, so this is okay to have a list of objects here, and then they have a body, which is another string. Fine, and you'll notice that this is actually JSON compliant. We looked at JSON in the Twitter assignment, and so it's another occurrence of this, and one of the reasons why I wanted to make sure you're working with JSON before is it does get popular, and so CouchDB, all data is represented in JSON, and all the requests coming back are all represented in JSON as well. Okay. So how do updates work in this context? Well, as we mentioned, they are, you can make it is fully transactional within a single document. So full consistency within a document, meaning that I can sort of grab hold of the document and logically sort of lock it and make it whatever updates I want. Now, it doesn't actually take a lock, because it uses what's called optimistic concurrency control, meaning that it sort of assumes that conflicts aren't going to happen optimistically. And so now if I check out that document and try to make updates to it anywhere I want all throughout it, and then try to commit that change, and someone else is doing the same, has committed their own changes in the meantime, my changes will fail. But we assume that doesn't happen that often, so it's okay to just sort of fail in those cases. And really all you have to do in that case is check out the new changes and make whatever changes you want. Fine. But there's no multi-row transaction. What I mean by multi-row here is multi-document, right? So you can't say, for example, when I update my status, I have to update my document that describes my current state of the world. But maybe I also want to update all my friends' walls, right? Their pages that reflects my new status. And you can't guarantee that happens synchronously in CouchDB. But, in this particular application and in many others, maybe that's okay. All right. You can do it in two separate steps. You update your status and then you update theirs, and there'll be a period of time when their, view of your current status is out of date, but maybe that's all right. Fine. All right, so this notion of views works like this. A view specification, which is itself a CouchDB document, a set of key value pairs, but it's sort of a special one, looks like this. There's some metadata information here, and then there's this key views, which is a dictionary of things. And so this specification has 3 views in it: one called all, one called by last name, and one called total purchases. And each one of these views is implementing a set of key value pairs. Right? It's going to be implementing a dictionary. And so the all view, okay, and so fine. So how are these implemented? Well, speaking of recurring concepts, views are recurring from logical data independence in relational databases. And here MapReduce is recurring, even outside the context of literally Hadoop. Okay. And so here the map function, reduce function are actually written in JavaScript. Again, everything in CouchDB is JavaScript. And they look like this. So the all view has just a map function, no reduce function. And in JavaScript, you can write these anonymous functions like in this sort of syntax. So this function doesn't have a name. It just says, hey, I've got a function with no name with a single argument called doc. And the body looks like this. It says, if doc.type equals customer, then emit a key value pair where the key is null and the value is doc. So we don't really care about the key in this case. We just care about the doc. All right, so this is all customers. Fine. The by last name view, you can imagine the key is going to be last name in this case. And so here we have another anonymous function. If doc.type equals customer, then emit the last name followed by the entire document. And so now this allows clients to search efficiently by last name. And these views are in CouchDB are computed, they're materialized sort of eagerly and stored in these distributed B-tree structure or index structures to support various lookups. And so this is how they implement those secondary indexes in that column in our table. Okay, so now we can look up by last name as well as by document ID. And so you can even go a little further. You don't have to just do simple key value pairs. You can even do a little bit of computation. So total purchases here, the map function again takes in a document and says, well, if doc type equals purchase, so I'm not talking about customers anymore, just purchases, then emit the key of doc.customer and the value of doc amount. But then we're also going to define a reduce function, and the reduce function adds up all the values of the amounts. And so here we have given a customer, if I give you a customer, you can return it's the total amount of all of its purchases. Okay, and CouchDB maintains all these views as things change with eventual consistency sort of semantics. And so we have a lot of things going on here with one concept. We have secondary indexes, we have logical data independence, we have map reduce computation. Okay, so I had checked the box in the table saying that CouchDB could do joins and analytics, and it's not really quite true. They're somewhat limited. So let me show you an example of how they do sort of joins. They have this concept of view collation, and what you can do here is write a map function in a view that looks like this. And so here we're trying to group together all the comments associated with a post. So it's sort of a join between the comments table, if you will, and the posts and the blog posts table. And so this map function is the same kind of thing we did in the map reduce assignment to do a join. This is what you have to do when you do a join in map reduce, is you pretend like the whole collection of documents, regardless of type, regardless of source relation, is one big set of objects. And then in your map function, you sort out which one's which and make sure to hash it on the same key. So here, the ID of the document post, and then in this document, doc.post refers to some post ID. And so now, post ID equal to 1 and all the comments associated with post ID equals 1 will go together. But they do this funny thing. They say the key here in the key value pair is document ID followed by the number 0 in the one case and the number 1 in the other case. And what's happening here is that everything in CouchDB is sorted. And so you've got things sorted by document ID and then sorted by this extra bit. And so now you have the post ID coming first and then all the comments coming second. And now what you could, you'd think that you could just do a reduce function to actually compute the join that you might want, but it turns out reduce functions don't quite work that way, and there's some scalability issues. So what people recommend is to do this view collation trick where you still spit out the data in sorted order, but then you can query it. Say a client application could query it like this, where they say start key is just the post ID without the extra prefix at all, and the end key is post ID with the number 2. And so now this gets the full range of the post ID which has the key of 0, followed by all the comments with a post ID of 1. So you got everything in one big list. And now you could process it in order to show it show it in the application. So you essentially constructed the join by cheating with the order. Okay. So fine. So perhaps you could argue that you have some joins in analytics, but it's a big glib to say so.